Nenomatica, where mathematics meets YouTube excellence. Example: we will solve two problems step by step, exactly following the algorithm shown. First, the infinite nested radical, then the rational equation with radicals. Problem 1. The infinite nested radical equals 16. We introduce a new variable for the repeating part. This turns the original equation into x times a equals 16. So, a equals 16 over x. But the definition of a says a equals the square root of x times a. We square both sides to get a squared equals xa. Now substitute a equals 16 over x and solve for x. Finally, because the nested radical is positive, we take the positive root x equals 4. Problem 2. Solve the equation. First, rationalize each denominator using its conjugate. Multiply the first fraction by x minus the square root of x squared plus x over itself, and the second fraction by x plus the square root of x squared minus x over itself. Now apply the difference of squares to simplify denominators. That gives negative 4 times x minus the square root of x squared plus x over x, minus x plus the square root of x squared minus x over x equals 3 over x. Multiply both sides by x, remembering x is not 0 because of the original right-hand side. Expand and collect radicals on one side. Now square both sides, expand carefully, and simplify. Bring all terms to one side to match the structure in the worked solution. Finally, analyze. The quadratic part has a negative discriminant and the radical term is non-negative, so their sum cannot be 0. Therefore, there is no real solution. Final results. For the nested radical, x equals 4. For the rational equation, there is no real solution. X equals 4. For the rational equation, there is no real solution. We will solve two radical equations exactly following a careful step-by-step algorithm. First, we display the example label and the problem statement in bold orange math. We start with equation 1. Step 1. Isolate the radical. Subtract 14 from both sides. Step 2. Divide both sides by 3. Step 3. Analyze feasibility. A principal square root is never negative. Therefore, square root of something equals negative 3 is impossible, so this equation has no solution. Now equation 2. We will follow the exact algorithm. Isolate, square, isolate the next radical, square again, rearrange, factor, then check all candidates in the original equation. Step 4. Square both sides of the equation. Step 5. Isolate the remaining. Step 5. Isolate the remaining radical by subtracting 2x from both sides. Step 6. Square both sides again. Step 7. Rearrange to set the equation equal to 0. Step 8. Factor the polynomial. Step 9. Check all candidates in the original equation to remove any extraneous roots created by squaring. Final results. For the first equation, there is no real solution. For the second equation, the solution set is curly brace 0, 2. Here is the example we will solve. The orange formula is the problem statement. Step 1. OCR and text extraction. We extract Latin letters, digits, and symbols, replace multiplication dots to times or dot operators, and present all formulas in bold latex. Step 2. Structural analysis. We will follow exactly the sequence visible in the source. Square both sides, isolate the inner root, square again, rearrange as a quadratic in A, solve for A, factor, then solve the two quadratics for x. Step 3. Square both sides. Since x is the output of a square root, we proceed with squaring to remove the outer radical. Step 4. Square again to remove the remaining square root, and then expand. Step 5. Rearrange so that it becomes a quadratic in the variable a. Step 6. Apply the quadratic formula with respect to a. The discriminant simplifies to the square of 2x plus 1, exactly as in the source. Step 7. Factor using a minus a 1 and a minus a 2, then split to two equations exactly as shown in the image. Step 8. Solve each quadratic for x. First, x squared plus 1 minus equals 0. Second, x squared minus x minus a equals 0. These yield 4 solutions as written in the source. Example: we will solve this radical equation step by step, exactly following the algorithm shown. The fourth roots are reciprocals. Apply the am-gm inequality, reach equality, and then solve for x and verify. Step 1. Define a substitution and analyze the structure. We denote a equals the fourth root of open parenthesis 2 minus x over 3 plus x close parenthesis. These two radicands are reciprocals, so the second fourth root equals 1 over a. Step 2. Apply the am-gm inequality for positive a. For a greater than 0, a plus 1 over a is at least 2. Because our sum equals 2, equality must hold, which forces a to equal 1. Step 3. Set it equal to 1 and solve for x. If the fourth root equals 1, then the radicand equals 1. We proceed line by line to isolate x. Step 4. Verify the solution. We substitute x equals negative 1/2 into the original equation. Set each factor equal to 0. We use the zero product property. If a product is 0, at least one factor is 0. Show the rule box. Add the step title. Set the square root expression equal to 0 or the logarithm equal to 0. Solve the radical branch. For a principal square root to be 0, the inside must be 0. Show the radical rule box. Add the step title. Convert the square root equation to a quadratic. Factor the quadratic. Write the candidates from this branch. Solve the logarithmic branch. Use the fact that a logarithm equals 0 when its argument equals 1. Show the logarithm rule box. Add the step title. Convert the log equation to an algebraic 1. Solve for x squared, then take square roots. Quick challenge. Before we check domains, can you predict which candidates fail? Check domain restrictions and validate solutions. Square roots require the radicand to be non-negative. Logarithms require a strictly positive argument. Show the domain rule box. Add the step title. Test x equals 1. Test x equals negative 3. Test x equals square root of 2. Test x equals negative square root of 2. State the final solution set. Present the two valid solutions in green. Example: we will solve a radical equation step by step. The problem is the fraction with numerator square root of 2x plus 2 plus square root of 2 minus 2x and denominator square root of 2x plus 2 minus square root of 2 minus 2x equals 1 over x. Step 1. Multiply both sides by the denominator to clear the fraction. Step 2. Move all terms to one side and group like radicals. Step 3. Pull a factor of square root of 2 out of each radical. Then divide both sides by square root of 2. Step 4. Multiply the entire equation by negative 1 to prepare a clean factorization. Replace 1 minus x by the square of square root of 1 minus x, and x plus 1 by the square of square root of x plus 1. That turns the expression into a product. Step 5. Apply the zero product property. Either square root of 1 minus x equals 0, or square root of x plus 1 equals 0, or the difference of the square roots equals 0. Solving each, the first gives x equals 1. The second gives x equals negative 1. For the third, square both sides to get 1 minus x equals 1 plus x, hence x equals 0. So our candidates are negative 1, 0, and 1. We must check the original equation. It contains 1 over x, so x cannot be 0. Therefore x equals over x, so x cannot be 0. Therefore x equals 0 is extraneous. The radicals require x between negative 1 and 1 inclusive, which is satisfied by x equals negative 1 and x equals 1. We label the problem as an example and display the original equation in bold orange. Step 1. Square both sides to remove the outer square root. This uses the rule, if the square root of a equals b, then a equals b squared. Squaring both sides gives 1 minus the inner square root equals x squared minus 2x plus 1. Step 2. Isolate the remaining radical term. We move terms so the square root stands alone. That yields negative square root of x to the fourth minus 4x squared equals x squared minus 2x. Step 3. Square both sides again to eliminate the inner square root. If negative square root of a equals b, then a equals b squared. We get x to the fourth minus 4x squared equals x squared times x minus 2 quantity squared. Step 4. Expand the square. We use the identity. A minus b squared equals a squared minus 2ab plus b squared. So x squared times x minus 2 quantity squared becomes x squared times x squared minus 4x plus 4, and then equals x to the fourth minus 4x cubed plus 4x squared. Step 5. Bring everything to one side and simplify. Subtract the right side from the left side. The result is 4x cubed minus 8x squared equals 0. Step 6. Factor the common term. Factor out 4x squared. We get 4x squared times x minus 2 equals 0. Step 7. Apply the zero product property. If a product is 0, then at least one factor is 0. So either x equals 0 or x equals 2. Step 8. Check both candidates in the original radical equation to guard against extraneous roots. 4x equals 0. The left side is the square root of 1, which is 1, but the right side is negative 1. So 0 is extraneous. 4x equals 2. Both sides evaluate to 1, so 2 is valid. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenomatica, where mathematics meets YouTube excellence.